Right, so here's a moments problem, and I want to show you that the pivot that we pick does not affect the final answer. The pivot you pick will choose how easy it is to solve the problem, or make it more convenient, but it won't change the final answer. Right, okay, so let's take the information and make sure we've got that all on the diagram. So we've got two pivots, two points of contact. We are told that the reaction at D is twice the reaction at C. So that means basically if I put in my normal reactions, I'm going to put that as 2R and that is R. Okay, this is a uniform beam of 40 kilos. So I'm going to put in the weight in the center, and now as it's 40G toward kilos, that we make that 40G as a force. Okay, the overall length is 5 meters, and it's 1 meter at the end and 1 meter at the other end. So the distance between the beams is, so between the pivots is 3 meters. We've got a man standing, and he is 80 kilos. So again, kilos gives us 80G. Right, now we've got to find a distance from A to E. Right, so the first thing we need to do is we need to find out what that reaction force is. So first thing we do is we resolve in the vertical direction. So going up, I've got 3R, 2 plus 1. And going down, I've got 120G. So that means that 1R is equal to 40G. Okay, now I pick my pivot. So I'm going to pick A to start. And I'm going to make it really clear that everything I do is about A. Okay, now A is good because I want the distance from A to E. So that should make it the simplest way to find that distance that I want. Right, so let's arrange our forces anti-clockwise and clockwise. So I've got the distance of 1 times the force of R. That's my first reaction force. Then I've got a distance of 4 times my other reaction force, which is 2R. They're going up, so they're my anti-clockwise. And in the clockwise direction, I've got the weight vector, which is in the middle of my 5 meter beam. So that's 2.5 times 40G. And then I've got my man standing on the beam, who's at an unspecified location. So we're going to call D for distance. We're going to multiply that by his weight, which is 80G. So that's all my forces. Right, now 1R and 4 times 2R, that gives me 3,528 newtons. And then on the other side, by 2.5 times 40G, that gives me 980. And when I do 80G times D, that gives me 784D. Right. Now I want to find out what D is. So I subtract my 980. So now I've got 2,548 equals 784D. I'm going to divide both sides by 784. And I get 3.25 equals the distance. So this is in meters. Okay. Now we started at A. So this is the distance from A to E. And I've answered the question. Okay. What if I didn't pick A? So let's pick B. So I'm going to do the same thing. I'm going to pick A and split my forces at A and C. So now remember, we are working from the point B. So now from B, in the anti-clockwise direction, remember anti-clockwise is going to go down that way. Clockwise is going to go up that way. So in the anti-clockwise direction, I have got my I've got my weight vectors. So I have got from B, again, 2.5 times 40g, because it's in the center. And then I've got the man's weight, which is d, the distance we don't know, times 80g. And that is equal to 1 times 2r, because the contact point at D is only 1 meter from B. And this time 4 times r for the contact point at C. Okay, so that's all my forces again. Right, so I've got 980, which we had from last time. 784D, the same as last time. That's equal to 2352, which means that 784D is equal to 1,372. I divide by 784, and the distance is equal to 1.75. Now, remember, this we measured from B, so this is the distance from B to E. So what we found is this distance, and that is 1.75. Okay, and we know the whole beam is 5 meters. So the distance that we actually wanted was A to E, so that's 3.25. Right, okay, so that means that A to E is 3.25, and that's the same as we got about A. Okay, well, if we pick another one, if we pick one of the pivots, so let's do it about C. Again, A and C. So now I'm working about point C. Right, so now in the anti-clockwise direction, 3 times 2r. Sorry. Oh, because the distance from C to D is 3 meters. I've now got 0 times r, because I'm working from C, and the distance from C to this reaction force is 0, so that's now 0. Then I've got 1.5 times 40g, because that's in the center of the beam. And then I've got D, the distance I don't know, times 80g. Right. So that gives me 2352. That's equal to 588 plus, as before, 784D. 1764 equals 784D. So 2.25 equals D. Remember, meters because it's distance. Again, we've measured from C to E. So we have measured from C to E, and that was that's 2.25. And as you can see, from A to C is 1 meter. So that means that A to E is 3.25 meters, as we got from the other two pivots. So as you can see, as long as you're consistent, a pivot might make it easier. When we picked A, we didn't have to work anything else at the end. With the other two pivots, we then had to work out what distance we were looking for, but we got the same answer.